All right, let's go over our performance review for this year. The first example, and this is going to be part one of the review. So the first example, we are going to use the continuously compounding interest formula. And that one is the one that I refer to as PERT. So it is A is equal to P E raised to the R T. Okay, so let's read what the scenario says. Yoon deposited $4,000 for 5 years, earning 7.5% continuously compounded interest. What is his account balance? So again, what we're looking for is actually what the keywords are to tell us which formula to use, and the keyword is continuously. So we're using continuously compounded interest, which I just stated. This is the formula for that. I refer to it as PERT. Now, I personally, on the side, I just like to always list my variables that are shown in my formula. So E is not a variable. It actually has a number assigned to it, just like pi. Okay, so once I'm reading this, I want to break it apart. What jumps out to me is 5 years. So I know that represents time, so I'm going to put 5 here. You deposited $4,000. So in previous videos, I explained to you that your initial deposit or your initial amount is your P. So I know that he deposited $4,000, and we already did the 5 years, earning 7.5%. Again, in another video, I told you that percent has to be changed to a decimal form. So instead of 7.5%, we're going to remove the percent sign, and we're going to take this decimal and move it over 2 places. Well, if there's nothing in front of that 7, guess what? I will put a 0 there. So my rate is actually 0.075. And again, remove the percent sign. Okay, now I want to keep reading. What is the account balance? Well, I have values for 3 of my variables, so I have to find one of them, which happens to be A. So let's go through and substitute what we know. Well, we don't know A. We know that P is $4,000. E, again, is represented as a number. R is raised to a power, so we're going to put in 0.075, multiply that times time, or T. And if you ever have where your variable is already on the side by itself, then all you have to do is just put this information in the calculator just as you see it. So I've highlighted, for the sake of time, how you would put it in a calculator, and then this is the answer. So $5,819.97, because we're talking about money, is what the account balance is. So as we're talking about money, $5,819.97. So even though you have more decimals, you want to make it look like money. So that's why we rounded it to 2 places after the decimal. Example 2, Jonathan's account balance in 2020 ended with $8,500 after earning 4% continuously compounded interest that began in 2014. What is his initial deposit? So again, I see continuously compounded, so that tells me that I am going to be using the PERT formula again. So again, I personally just like to write it so that it's easy for me to substitute my information in once I write it to the side. So RT, and let's read through it again. So what jumps out? It ended at 8,500. So a few minutes ago, I said it started means it's P. Well, if it ended, that means that's your A. And typically sometimes you'll see it as A of T. It means the same thing. So if you see it written as A of T, it means it's your A. So I'm going to put 8,500 here and keep reading. After earning 4% continuously compounded interest. So again, 4% is written as a percent. I need it to be changed to a decimal. So I'm going to move the decimal point over, which is currently, anytime you just have a whole number, the decimal is currently after that number, and you just move it over 2 places. And again, you would have to put a 0 in front of it. So 0.04 and get rid of that percent sign. And it began in 2014. What was his initial deposit? So we're trying to find P this time. But T is not just given to us. We actually have to do some work. So you're given 2 years. You're giving 2020 and 2014. So all you would do is just take the difference between the two, which tells you that your time is 6. So 6 years. Now I'm going to substitute this information in. This time A actually has a value. So on the left-hand side of the equal sign, I will put the 8,500. P does not have a value, so I'm just going to simply put P. E is a number in itself if you put it in the calculator. And R is 0.04, and it's multiplied times T, which we said was 6. For this particular type problem, because I have a value on the left-hand side and it's not just a variable, I actually have to do some math here. So I can't just put this in the calculator. What I would do for now is just take the entire, everything that's stopping P from being by itself, and that's what I'm dividing both sides by. So that's going to be E raised to the 0.04 times 6. And of course, you can go ahead and multiply the exponents, but I'm just going to leave everything as it is. And that's what I'm going to put in the calculator. So on the right-hand side, in order to get rid of, I'm getting rid of everything that will stop P from being by itself. So if I cross that out, guess what? P is by itself. So I'm going to flip my, I like my variable on the left-hand side, so that's what I'm going to do. And now what I'm going to do is show you what I put in the calculator. So the part that's highlighted, I put the 8,500, I divided it by E. E can be accessed by hitting second and then natural log. And it's automatically going to give you a box for your exponent. And so you can just go ahead and put in that information that's shown here in the problem. And your answer would be $6,686.34. Okay, I put all the work in the calculator again to save time. So I have $6,686.34. Moving on to example 3. Jared invested $1,500 in an account paying 11% compounded continuously. I wish there was some 11% compounded continuously interest going on. I would run to that bank. If no deposits or withdrawals were made, how long would it take to the nearest tenth of a year for the value of the account to reach $6,500? So again, we're talking compounded continuously. There's that word continuously. So we're going to use that PERT formula again. A equals P E raised to the RT. Now, what you should notice is that I'm finding different variables each time. I'm using the same formula, but I am not always finding A or P. So let's see what we got. Okay. That R is just not doing it for me. Neither is the T. All right, so R and then T. Jared invested $1,500. So that is what he initially put into the pot. So that's my P. And the account is paying 11% compounded continuously. So I know that's my rate. However, I have to convert it. And again, if I have a whole number, my decimal is automatically after that number. So I'm going to get rid of the percent sign and I'm going to move the decimal place over 2 places, 1, 2. So now my decimal is in front of that 11. So that's 0.11. Looked like a happy face, didn't it? Okay, how long will it take? So I already know I'm trying to find T this time for the value of the account to reach 6,500. So that's where I'm trying to end up. That's my end goal. So 6,500. I go to my formula and I substitute what I know. I know that A is 6,500. I know that P is 1,500 and E is a number in the calculator. R is raised to the 0.11. And again, it's very important that you get your decimals correct. Because I'm trying to find T, I don't have to put it in parentheses actually. So that's E raised to the 0.11 t. And now what I want to do is I always want to get rid of what's in front of that e. So that's 1500. So once I get rid of that 1500, on the other side, I see 2 zeros, so I'm going to automatically get rid of that. For me, I am going to go ahead and just work with this fraction, 65 over 15, which you really can reduce to 13 over 3, but I'm just going to leave it this way. And I'm left with e raised to the 0.11 t power. This is where a lot of people get stuck. You have to recall, we're talking logs and natural logs. So you're going to rewrite this one, but this time, since there's an e, you're going to rewrite it as a natural log. So I'm going to write it in the opposite direction. So hopefully that won't confuse anyone. So I'm going to take my natural log. You really don't have to write the base e. I just like to keep up with it when it's given. Follow my arrows, 65 over 15, or if you chose to use 13 over 3, that's fine as well. And now what's left over, since you rewrote that, is 0.11 t, but t is still not by itself. So to get it by itself, you have to divide both sides by 0.11. So I am going to rewrite it with my variable on the left-hand side. T is equal to, I have to go back to my instructions, which ask me to round it to the nearest tenths of a year. So I can't leave it in the form that it's currently in. I put it in a calculator as natural log. And of course, you don't have to put the E, it's given once you press the natural log button. And then you can put in the 65 over 15, or if you reduced it to 13 over 3, it'll give you the same number, divided by that 0.11, and then your answer will be 13 point, and all of these decimals, however, it says to the nearest tenths, which means one place after the decimal. So it's going to be 13.3, and it's in the form of years. 13.3 years. That's how long it will take to go from 1500 to 6500 at that current rate. Okay, example 4. Zeta deposited $3,000 for 8 years, earning 2.9% semi-annually compounded interest. What is her account balance? Well, this time we have the word semi-annual, annually. So that means we're no longer using that compounded continuously compounded interest formula. We're using a different formula. So this time, the formula that we will use, let's just change it up, is going to be still using A, and sometimes it's shown as A of t is equal to P times 1 plus, this time it's R over N, all raised to N to the T power. So whatever you have on your denominator is the first thing that's going to show in your exponent. So some people get that confused. All right, again, for me, I personally like to write to the side what each variable represents. So that's what I'm going to do over here. And let's go back and let's read. So Zeta deposited $3,000. So that means that's what she initially put into the bank. So $3,000 is my P for 8 years. I don't have to do any calculating. They just told me the time is 8 years, earning 2.9%. I know that's my rate. However, I have to get rid of the percent part and move the decimal over 2 places, which leaves me with a rate of 0.029. And semi-annually, you have a cheat sheet, so make sure you use that. Maybe I shouldn't use that word cheat sheet. You have notes. So semi-annually is going to be 2. And what is her account balance? So I should have information for everything except one variable. That one variable that does not have information is the one I'm trying to find. So when I am actually doing my work, that variable stays the same. So A is A. Now, what I see is that A is already by itself. So that tells me once I substitute everything in on the right-hand side, I can automatically just put it in the calculator. So P is 3,000. It's multiplied times 1 plus the rate is 0.029, all divided by 2. And I take that same 2 and I'm going to raise it to a power, and I'm going to multiply it times the time, which is T of 8. A equals, And again, for the sake of time, I already put it in the calculator, and this is what I put in. I personally like to use a parentheses within a parenthesis. If you do use parentheses, don't forget to put that second one. It'll throw your answer off otherwise. And so the amount, again, we're talking money, is $3,777.06. Okay. Money is $3,777.06. That's a decimal. Okay. We're getting close. We got two more. Example 5. Eric is going to invest in an account paying an interest rate of 5.3% compounded monthly. So again, I'm still using that same formula. However, my end will change because it's monthly now. How much would he need to invest for the value of the account to reach $123,000 in 14 years? So let's go ahead and write to the side APRNT, because I know those are the variables that are going to be used in my formula. And again, my formula is A is equal to P times 1 plus R over N, all raised to the N T power. I personally, like I said, I like to write the formula each time. You are not required to do that. The interest rate, I'm told, is 5.3%. By now, you should understand how to do that. So that's 0.053. Compounded monthly, your notes should tell you that that means 12 because there's 12 months in a year. How much would he need to invest? That means, what do I need to start with? I'm looking for P. Invest for the value of the account to reach. So what do I need to end up with? 123,000 in 14 years. See, take it step by step. It should be pretty easy. Substitute what you know. Well, I know A is 123,000. I know that P is what I'm looking for. 1 plus R is 0.053. N is 12. I'm raising that to, again, 12. So again, my denominator and my numerator should look exactly the same. And in addition to that, I still have to multiply times the T, which is my time, 14. Okay, having issues here. 14. And I cannot just put this in a calculator because I have information on the left-hand side. So what I would do is I would divide both sides by whatever is stopping P from being by itself, which is this entire 1 plus 0.053. I don't try to simplify it first. I'm just going to go ahead and divide it right away. So this same information will go on this side as well. So once that happens, I have one in the numerator and one in the denominator. So I can just go ahead and scratch that out. That part goes away. And some people probably need to see it. Let me just write it. 1 plus 0.053 over 12. 12 times 14. So that goes away, which leaves me with just P. I'm going to write the variable on the left-hand side. That's just what I do. And now I can put this entire thing in my calculator exactly like that. So that's what I'm going to show you. I'm going to go down and I see 123,000 divided by, again, pay attention to where I put double parentheses on the end because I have two parentheses out front. Otherwise, it's going to throw your answer off. And my final answer is $58,663. And this time I have to round it to 52 cents. I'm sorry, I don't round it. It's 52 cents. But pay attention to the rounding up here. I don't know if I said it, that it should have rounded. Pay attention to that. If it's 5 or greater after the number that you're trying to round to, then you would add 1 to the number in front. All right, so for this one, I said it's still money. So $58,663.52. That's what Eric would have to invest in order to reach 123,000 in 14 years. And last one, Haley invested 5,600 in an account paying an interest rate of 4.8% compounded quarterly. Assuming no deposits or withdrawals were made, how long would it take to the nearest tenth of a year for the value of her account to reach $23,080? So again, I see that we are compounding quarterly, which means I am going to use that formula. A is equal to P times the quantity of 1 plus R over N raised to the N T power. Over to the side for me, visually, I'm going to list all of my variables and then read through my word problem or my scenario so I can substitute correctly. So she invested $5,600. That's what she began with. So she has a P value of 5,600. The account paid an interest rate. They're telling you that rate is going to be 4.8%. We just can't leave it in percent form. We have to change it to decimal form, which means we have to move the decimal 2 places in front. So the rate is 0.048. Compounded quarterly, if you look at your notes, quarterly is telling you that N is going to equal 4. And since there were no withdrawals or deposits made to the nearest tenth, we know our answer is going to be in the nearest tenth. What would it take for her value to reach or end with $23,080? So to end is going to be your A of T or A. And again, I have all of my variables accounted for except one. So the one that's not accounted for is what I'm looking for. Substitute what I know. I know A is 23,080. P is 5,600. The formula tells me to take 1 plus the rate, which is 0.048, divided by, let's write a little neater here. So 0.048 divided by N, which is 4. Take that same N and multiply times the time, which we know we don't know. So that's what we're trying to find. So you don't have to put it in parentheses. Oh my gosh. Okay, 4T. Now, what we want to do is get rid of what is in front of this part. So that means you're going to divide both sides by 5,600. That's the way I would do it. And anytime I see like zeros on this side, I just go ahead and get rid of it. So they both each end in 1 0. So I get rid of the zeros. So I'm going to bring down 23. 08. So 2,308 divided by 560, which can be simplified if you wanted to 577 over 140, but I'm just going to leave it. And I am going to go ahead and simplify what's inside of the parentheses, which will be, let's go back here, 1.012. So what I did was take 1 plus, and then I put this part in parentheses and then use another parentheses. That's what I did in the calculator. And I raised all of that to the 4T power. So again, this is where students get stuck. You want to rewrite this in log form. Rewrite as log. So we should know rewrite this in log, not natural log because it's not an E this time. We actually have a base. So I am going to take that base and I'm going to write it in reverse. So I'm going to take log of base, what's in the parentheses, 1.012, log base 1.012 of, and this entire fraction, unless you simplified it to 577 over 140, you can use that as well. So 2,308 divided by 560, and it's set equal to 4T. Well, T is still not by itself, so I have to divide both sides by what's stopping it from being by itself, which is 4. Now, my instructions ask me to round it to the nearest tenth, so that means I can't leave it in this form. I'm going to actually have to put it in a calculator. So now for this one, I don't think I put it in a calculator because I wanted to show you. Yeah, I didn't. So say, for instance, you're one of those people, well, you don't have a calculator that allows you to change your base. So what you can do is use the change of base formula. Some of you are still struggling with that part. All you have to do is under your log, just draw your line just like that, right? So this is really telling you you're going to put in a calculator log 2,308 divided by 560, and then divide that again by this same log, but this time you're going to use that base 1.012. Take this whole answer and you have to divide it by 4. So let's do it. I'm going to show you both ways. All right, so where's my calculator? Here we go. So I'm going to type in the log, if I can get my cursor going. All right, so log and then parentheses 2308 divided by 560. All right, and then I'm going to hit my division button, which is like a fraction, and I'm going to hit log again and type in 1.012. Whatever that answer is, oops, I accidentally pressed whatever that answer is, I'm going to divide that by 4. And I did something wrong. What did I do wrong? I know what I did wrong. Okay, so let's try that again. All right. So log parentheses is, I probably put another parentheses in when it was already there. I think that's what I did. 2308 divided by 560. So parentheses matter. Divided by, again, log 1.012 in parentheses equals, and I divide that by 4. Yep, this is the correct answer. So what I did the first time that was incorrect is I put an extra parentheses over here. So I have 2 parentheses, but only 1 over there. See how I threw your answer off or my answer off? That is not correct. This one's not correct. This one is. So it should round to the nearest tenths based off of your instructions, which is 29.7. So let me show you those people who actually have the calculator that will allow you to put it in just like this. You would just go to math. You can either scroll all the way down until you get to A, which here I don't use that. I just go math and then alpha. And since there's an A here, that was the purpose of me pressing alpha, I just hit math again. Either way works. But you see now I can put the base in, which is 1.012. Move your arrow, and then you're going to put in that entire fraction, which is 2308. A fraction means divide, and then 560. Over to the side, you want to arrow over. Now this time you can go ahead and hit division and then choose the 4. You can do it all in one step. You could have did it a few minutes ago as well, and you still get the same answer, which is 29 point, again, we're rounding, 29.7 years. Whew. So 29.7 years is how long it would take for her value to reach $23,080 if she started off with $5,600 with a quarterly compounded interest rate of 4.8%. Okay, so I am going to leave that mistake in there. I'm not going to edit that out because I want you to see how important it is to keep up with your parentheses, because it will definitely throw your answer off. Please make sure that you subscribe, thumbs up, all of that good stuff. Have a great day.